Hello everyone, in this video I will first talk about the background of kernel density visualization KDV, and then I will illustrate how our system can support KDV to interactively generate a heat map in near real time, which is more than 5 seconds. KDV is a commonly used visualization tool in a wide range of applications, including traffic accident hotspot detection, crime hotspot detection, disease outbreak detection, etc. Therefore, the most popular geographical software, for example QGIS, ArcGIS, can also support this operation. As you can see here, QGIS offers this heat map operation, which is based on KDV to generate the visualization. Once you double click here, you can specify the number of pixels here and the kernel function here. The default kernel function is quadratic kernel. Although QGIS and ArcGIS can support KDV, they cannot support generating interactive KDV, which means the heat map does not change after you perform the zoom in, zoom out, and panning operations. To the best of our knowledge, none of the web-based systems has been developed for supporting KDV with interactive operations. The main reason is that computing KDV is very time-consuming, which cannot support real-time heat map generation with more than 100,000 data points, or can consume too many computational resources to support KDV in real time. Using the crime dataset here as an example, this dataset contains 270,000 data points. If we generate KDV for this dataset using this QGIS software, it takes us nearly 5 minutes for a single visualization. In this demo, I will show you that our system IKDV-SYS can support near real-time heat map generation for a dataset with median scale data points under the single CPU setting, which means first, no GPU, and second, no parallel computation. Here, we use the traffic accident dataset in New York for demonstration. This dataset stores the latitude and longitude coordinates for the traffic accident events. The total number of these events is nearly 1.3 million, which is 4.8 times larger than the crime datasets that I've shown you before. Now let's generate KDV in New York. Even though this dataset contains 1.3 million data points, we can find that IKDV-SYS can instantly generate a heat map. You can see that Manhattan here seems to have the high density for traffic accident events in New York. As a practical users, for example, transportation experts, you can have more questions. For example, which region in Manhattan is the hotspot of traffic accidents? Therefore, IKDV-SYS offers the zoom in, zoom out operations for the user to visualize more interesting regions in province level, city level, or street level. Now let's zoom into Manhattan. Change the bandwidth to 15, and then click 1. Then we can instantly generate another heat map which shows more detail compared with the previous one. For example, you can see that this region and this region are the hotspots of traffic accidents. Besides the zoom in operation, the users can be interested in visualizing hotspots in other regions. Therefore, IKDV-SYS offers the panning operation. Now let's pan the screens to the south part of New York. And then click 1 again. You can find that this part is also the hotspot of traffic accidents. Besides the traffic accident datasets, our system also provides other datasets for visualization. For example, COVID-19 datasets and crime dataset in Atlanta. As the concept is similar, I will not show the demonstration in these datasets in this video. To conclude, we have developed the first web-based and interactive visualization system, which is called IKDV-SYS, for efficiently generating KDV. The 3 main properties for this system are that first, it offers interactive operations, including zoom in, zoom out, and panning. Second, it does not consume many computational resources for generating a single KDV. That means single CPU is enough. Third, it computes KDV for median scale data sets in near real time, which is more than 5 seconds.